Welcome to the Explainer. Okay, if you're an architect who's been wrestling with how to get AI integrated into your network efficiently, in a way that can actually scale, then this is for you. Today, we're unpacking a really critical piece of 5G advanced infrastructure, the AIMLE service. Honestly, understanding this is pretty much non-negotiable if you want to build next-gen intelligent services.
So here's our game plan. We're going to start with the why. Why does the standard even exist? Then we'll deconstruct the whole architecture, see how it actually works in practice, explore the different roles it can play, and then we'll wrap up with the really crucial takeaways for you as an architect. All right, let's get into it. All right, first things first, let's set the stage. We all know AI is moving from just being in the cloud to being, well, everywhere. We're talking smart factories, autonomous cars, you name it. And that means our networks have to get a whole lot smarter to keep up. But here's the problem. Trying to build all that intelligence with custom, one-off solutions for every single use case, it just creates a tangled mess. It doesn't scale, it's not efficient, and believe me, it is a nightmare to manage.
And that really is the core challenge, right? Without a standard, you get this chaotic landscape where every single application developer has to build their AI infrastructure from scratch. And that means they're constantly reinventing the wheel for things like model training, data management, performance monitoring. It's a huge barrier to getting things to work together, and it absolutely kills the pace of innovation. So the third-generation partnership project, 3GPP, they tackled this problem head-on in Release 20. And what they came up with is the AIMLE service. The best way to think about it is like an operating system, but for AI inside the network. It provides all these common services and standardized APIs that any application can just hook into and use. So how exactly did 3GPP structure this AI operating system? Let's pull up the architectural blueprint itself. This is where we can see the core components and, more importantly, how they all fit together.
Okay, this is our map. And as you can see, the AIMLE service sits right inside something called SEAL. That's the Service Enabler Architecture layer. Think of SEAL as a common middleware layer that offers up reusable capabilities. It's basically the bridge between the vertical application layer, or VAL, that's where your apps like autonomous driving live, and the underlying 5G network. Now let's break down the three main components here. At the very heart of it all, you have the AIMLE server. This is the central brain, the control plane for all the AI and ML operations. It's the core piece that orchestrates the entire service, everything from training models to monitoring how they're doing in real time. Then there's the AIMLE Client. This is the consumer of all these powerful services. It usually lives right alongside your application on the user device, the UE. It's what enables the AI capabilities right at the application level. So for an autonomous car, this client would be the part making requests to the AIMLE server for things like, say, updated navigation models or new traffic predictions. And finally, the ML repository. This basically serves as the system's memory. It's a logical thing, a centralized library that stores, registers, and manages the actual machine learning models and all the metadata that comes with them. Now, this slide is where it gets really important for an architect. These reference points you see, they're basically standardized APIs. They define the exact contract for how these different pieces talk to each other. For instance, AIML-UU is the API that every client on a device will use to talk to the network server. And this isn't just a suggestion, it's the standard. That's the magic sauce that guarantees that a solution from one vendor can actually work with another. Okay, so we've got the blueprint down. Now let's see how these pieces actually work together to get things done. This is where the architecture really comes to life through a set of defined standard procedures. Just think about what this means for a basic but vital operation like training a new machine learning model. An application doesn't have to build its own complex, super expensive training infrastructure anymore. Instead, it just leverages the network by following this simple, standard procedure. It requests the training, the server authorizes it, and the app just gets a notification when the new model is ready to go. It is incredibly efficient. And this sequence diagram illustrates that interaction perfectly. You see the VAL server sends an ML model training request. The AML server then runs an authorization check, which is a critical security step, sends back an initial "got it" response, and then goes off to do the heavy lifting of the actual training. Once that's complete, it sends a final notification back to the VAL server. Simple as that. But look, training a model is really only the first step. The real challenge is managing it out in the wild, in production. A model isn't static, right? Its performance can degrade over time. And this procedure tackles that problem head-on. An application can subscribe to the AIMLE server to monitor a model's performance. And if the server detects that performance is slipping, it can trigger corrective actions, like retraining. That's a core MLOps principle built right into the standard. Now, the AIMLE server is more than just a passive tool. It can play different strategic roles in managing the entire ML workflow. And this flexibility is absolutely key for you as a system designer. So you basically have two ways you can use it. On the left, you see the full manager mode. In this scenario, the app just says, hey, I need a model that does X, and the AIMLE service handles everything from data prep to deployment. Then on the right, you have the offloader mode. This is where the app stays in control but says, hey, network, can you handle this really heavy-duty training task for me? What this means for you as a system architect is you have a really critical design choice to make. You can go with the full lifecycle manager role to dramatically reduce complexity for your application developers. Or you can use the task offloader role when your app needs more fine-grained control over the whole workflow, but you still want to leverage the network's power for those specific resource-heavy jobs. And what's cool is these roles can be distributed across the entire network. This diagram shows a hierarchical deployment, which is incredibly powerful. You can have local AIMLE servers out at the network edge doing low-latency tasks, all coordinated by a central AIMLE server. This is the exact architecture you would need for advanced use cases like federated learning. You could train models on local data at the edge without ever moving that sensitive data, and then just aggregate the learning centrally. It's a total game changer for privacy and for efficiency. So after this whole tour of the AIMLE blueprint, what are the most important things to remember? What should you take back to the drawing board when you're designing the next generation of intelligent applications? First, standardization. This means you can build a service once and deploy it across any compliant 5G network. Say goodbye to vendor lock-in. Second, abstraction. Your developers don't have to be network experts. They can just focus on building great AI, which dramatically speeds up your time to market. Third, flexibility. This architecture isn't rigid. It adapts to your use case, whether you need low-latency AI at the edge or massive processing in the core. And finally, lifecycle management. This is what turns AI from a cool science project into a robust, manageable, production-grade service. Look, this framework opens up a whole world of possibilities. We're talking massive-scale IoT analytics, real-time augmented reality, you name it. Now that the foundational plumbing is finally in place, the really exciting question is, what will you build on top of it?